Hello everyone, this is Vasanth, a ninepointer at IIT Bombay from the Department of Civil Engineering. Today we are going to deal with axial loading. So we already know the different types of loadings. That a civil engineering structure can be subject to. One of that different types of loading is axial load, right? So let us go with the definition. So axial load is equivalent opposite force acting along the longitudinal axis of the member. So if this is the member, then what is longitudinal axis? Longitudinal axis will be perpendicular to the cross section. So this is the longitudinal axis of this member, right? So we need to apply equal and opposite force along the longitudinal axis. Equal and opposite force along the longitudinal axis. This is known as axial load. So why equal and opposite force? Because I already said in first lecture, load has two consequences. One is internal forces and other is deformations. So to cause deformations, it should create equal and opposite force, right? So that is the reason why it should be equal and opposite force, right? So either it should create equal and opposite force or you should apply equal and opposite force. Means if you make the member fix to a support, then when you apply load P like this, then it will automatically create opposite load P here, right? Then here also it is equal and opposite. It will create both internal forces and deformations. So this member is in equilibrium, right? So we can use equilibrium equations. So you can apply the load in two ways. One is away from the cross section and one is towards the cross section. See, if you apply the force away from the cross section, then it is known as tension. That is tensile force. If you apply the load towards the cross sections, then it is known as compressive force, right? So tensile force will try to stretch the body, i.e. it will try to elongate the body. But compressive force will try to compress the body, right? It will shorten the length of the member. So we need to have some sign conventions to clear confusions during solving problems. So we generally take tensile force as positive and compressive force as negative. So load has two consequences. One is internal forces and other is deformations. Today we are going to study internal forces at every cross section. So we already said that there are three tools which we use to understand these internal forces and deformations. So those three are equilibrium equations, compatibility conditions, stress strain relations, right? So out of these three, we are now going to use equilibrium to find out internal forces at every cross section. So one more thing is that if this body is in equilibrium, then every part of this body will be in equilibrium, right? So that is the concept to understand the internal forces at every cross section due to axial load. So let us understand this by solving a problem. So suppose this is subjected to load 25 kilonewtons here. This is subjected to this is some 30 kilonewton, some 60 kilonewton. Here it is applied 65 kilonewton. So find load at every section. Right. So first of all, if you observe this, the net forces on this member is 25 minus 65 minus 30 minus 60. That means is equals to 0, right? So net force on the body is 0. It means it is in equilibrium, right? So if you want to calculate load at this section, we can use this part, equilibrium, for this part of the body, right? So this is 25 kilonewtons. So let us say this is section A, this is section B, this is section C. So we said that tensile is positive, right? So away from the cross section is positive. So away from the cross section is P. So we apply equilibrium equation. So P minus 25 is equals to 0. So P is equals to 25 kilonewtons. Means positive. That means tensile, right? So we can use this part of the body also. See, if you use this part of the body, then it is like this. So 60, this is 30, this is 65. And see, again, tensile is positive. That means away from the cross section is positive. This away from the cross section P is positive. So again, apply equilibrium equation. Sigma fx is equals to 0. So minus P minus 65 plus 30 plus 60 is equals to 0. I.e. P is equals to 25 kilonewton tensile. Right? So this is for section A. For section B, so for see, for whole section A, at every cross section the load will be 25 only, because there is no intermediate loads here. From here to here there are no intermediate loads, right? So at every cross section the load will be 25 only, and that will be tensile. So similarly for section B, in section B also there is no intermediate loads, right? So for whole section B there is only one value of load, right? Constant value of load. So if you take this one, so this is 25, this is 65. Again, tensile is positive. Away from the cross section, P is positive. So again, equilibrium equation sigma fx is equals to 0. P minus 65 minus 25 is equals to 0. That means P is equals to 90 kilonewton tensile. So you can solve from this side also. Okay. So now let us go to section C. If you cut section C, see, you can take right side part because it is easy to solve. $60 kilonewtons. So away from the cross section is positive. So P, again equilibrium equations. P minus 60 kilonewton is equals to 0. That means P is equals to 60 kilonewtons. Means positive, i.e. it is tensile, right? So we got every section is under tensile load in this problem. So let us draw the diagram. Axial loading diagram. So this is axial load P. Axial force भी बोल सकते हो. Axial force diagram. So this is X. This is along the length. Means, see, we are starting from here. This is load P and we are taking length. This is X. Okay, like that. So in first section the value is 25 kilonewtons tensile. Means we take tensile as positive, right? So 25 kilonewton positive, right? In section B, the how much is the value? The value is 90 kilonewtons tensile. In section C, the value is 60 kilonewtons tensile. So suppose let us take this as 0.1, 0.2, 0.3. Okay. Then this 1, 2, this is plus 25 kilonewton. This is 60 kilonewton. This is 90 kilonewton tensile, right? So, okay, if you observe this part exactly at 1, you observe exactly at 1. So, what is the value of load exactly at 1? So, if you take 1 minus, means it will be in section A, then the load at that section will be 25, right? Tensile. If you take 1 plus, means just right side of 1, then the value of the load is 90 kilonewton tensile, right? So see, there is jump discontinuity at 1, right? Because the value of function is immediately changing from 25 to 90. So there is jump discontinuity. So the graph of Px is discontinuous at 1. Similarly, it is discontinuous at 2 also, because 2 plus में value 60 है, 2 minus में value 90. Okay, so the graph of Px is discontinuous at 1. So mathematics says that if graph is discontinuous, at a point, then value of the function is not defined at that point. So we can't define the value of load at 1 and 2. That is given by mathematics itself. So this is basic calculus, right? So with this we end this example problem. Before ending this lecture, we go with one question, simple question. So there is a bar and it is applied with 25 kilonewton force here, and here it is applied with 50 kilonewton. So what is the internal force, i.e. load, at each section, right? So this is the question. If you first of all, if you sum the net forces on this body, it is minus 25 plus 50 kilonewtons, right? So it is 25, right? It is not is equals to 0, sigma fx, right? Means it is not in rest. See, it is moving like this. So we can say like this, right? This 50 will consist of 25 kilonewton load, 225 kilonewtons load, right? This will consist of 225 kilonewtons load. You can say that 125 kilonewton load here and other 25 kilonewton load here are forming a pair, equal and opposite force, right? So that will create deformations and internal forces. And another 25 kilonewton load which is applied at this cross section will try to move the object, right? It will not cause any internal forces and deformations. It will just try to move the object. So this body can be said has superposition of these two things, right? 25 kilonewtons load plus 25 kilonewton load plus that body with 25 kilonewton load, right? Suppose it has mass m, so then it will accelerate with a is equals to 25 by m, right? So it will cause, this is load, so it will cause internal forces and deformations, right? This will cause motion. So load at every section load at each section Pi means P internal force is equals to 25 kilonewton tensile. Understood? So with this we are going to end this lecture. In next lecture we are going to deal with normal stress. Thank you from ninepointer.